Hey sixth graders, this video is on evaluating expressions and solving equations. So please make sure that you either have the packet in hand and find these notes that are, I believe, labeled for Wednesday, February 3rd. Otherwise, you can print these and the PDF is in today's folder under the to-do list, or you can upload that PDF to Notability and then split screen with this video so that you are able to follow along with the video and the notes template. So our learning targets are being able to evaluate expressions and solve equations involving variables when values for the variables are given, understanding that a variable represents any value that makes a statement true and may represent one value, many values, or no value, and understanding that a variable can be used to represent a quantity that can change, often in relationship to another changing quantity. All right, so how do we evaluate algebraic expressions? When we evaluate an expression, we are finding the value of the expression, which also means that we are solving it. This is an example of a numerical expression because it only has numbers and operations. And I solve it using PEMDAS. 3 times 4 is going to be first, so 12 plus 5 minus 6. Then I solve addition and subtraction left to right, so 12 plus 5 is 17, minus 6 would be 11. If the expression has a variable, we call it an algebraic expression. So an algebraic expression has numbers, at least one variable, I should say at least one number, at least one variable, and at least one operation. And then when we are given an algebraic expression, we need to replace the variable with the given value. This replacement of the variable is called substitution. So these are all wonderful vocab words that you'll want to circle or box or highlight so that you are able to find easily and remember. So substitution, or substitute the value of the variable into the expression, and then like we did above, follow the order of operations, which is PEMDAS. So evaluate if x equals 4 and y equals 3. So the first thing I'm going to do is substitute my algebraic expression. Algebraic because it has a number, it has at least one variable, and at least one operation. So I'm going to rewrite it first before I try to do this in my head. So 4 plus 16 minus 3. I only have adding and subtracting, so then I solve left to right. 4 plus 16 is 20, minus 3 equals 17. And I keep it nice and neat and organized, and I circle it. 2 times 9 minus x. So I'm going to rewrite it. 2, and then I'm going to even just keep my parentheses. 9 minus, and we know x is 4, so I'm just going to substitute in a 4. Notice I keep the exact same operations given. All I'm doing is substituting a 4 in for x. So I do parentheses first, so it would be 2 times 5, because a number outside of parentheses automatically means multiplication. 2 times 5 equals 10. And then we have y plus 8 divided by, remember this slash right here means division. So I'm going to rewrite it. Y is 3, so 3 plus, I'm going to keep those parentheses, 8 divided by, I'm just going to rewrite it with my division symbol just to keep it easy for me, divided by 4. Now I do my parentheses first, so I'm going to keep my 3 and my addition sign. 8 divided by 4 is 2. 3 plus 2 is 5. So here's a couple more examples. Evaluate 6x minus 7 if x equals 8. So I want you to notice that we start out with 6x minus 7 here, and then it's rewritten as 6 times 8 minus 7. Then they follow the order of operations, and they get 41. 5m minus 3n if m equals 6 and n equals 5. So notice that the 6 is substituted for the m right here, and the n is substituted, or the 5 is substituted for the n right there. They use order of operations, and then they get an answer. So 5m, and it says m equals 6. I just want you to notice that 5m then would be rewritten when we substitute it as 5 times 6, or 5 times 6. Not 56, because 5m is the same as 5 times m. So I want you to be careful when you write that down and make sure that you're including the multiplication symbol in there when you substitute that in. All right, I would like you to pause and try these 3 problems, show all of your work, and then come back and check. So we have G equals 7, H equals 1, and K equals 4. I like to box it and highlight it so it's easy for me to find for each problem. So 3 times G plus G, because remember 3G is the same as 3 times G. So 3 times 7, because G equals 7, plus 7, and then I follow order of operations, and I do multiplication first, so 21 plus 7 equals 28. K squared, K to the second power times 5, so K is 4. 4 squared minus 5. 4 squared is the same as 4 times 4, which is 16 minus 5, and we get 11. And then G plus H divided by K, so 7 plus 1 divided by 4, so 7 plus 1 is 8 divided by 4, and we get 2. Real-world expressions and equations. Sharon drives 8 miles each time she visits her grandmother. Sharon visits her grandmother V times. You can write an expression for the number of miles Sharon drives to visit her grandmother V times. Well, we know if she goes 1 time, she's going to go 8 miles. If she goes 2 times, we know that she's going to go 16 miles because it's 8 miles each time. 3 times would be 16 plus 8 would be 24. So we can see a pattern here that every time she goes, it's being multiplied by 8 miles. So we can write this then as 8V, and V is the number of times she visits her grandmother. Coach Martinez buys a small ice cream cone for each of the 18 players on his baseball team. Each small ice cream cone costs S dollars. The taxes come to $2.16. He spends a total of $38.16. You can write an equation to represent this situation. So notice up here we did 8V, and this is an expression because V can change based on how many times she visits her grandma. So this doesn't equal anything. If it told me how many times did she visit her grandma if she traveled 56 miles, then we would know there's a solution for V. But it's just telling us here, what's the expression, what can I plug in for V for however many times she goes. Here we have an equation and we only have one value for S. We want to figure out what's the price of the ice cream cone based on how much he spent. So he has 18 players. Each one had an ice cream cone, which we don't know how much it is, but however many ice cream cones the coach bought, which is 18, we know that it needed to be multiplied by S, and then he had to pay for tax on top of it. So we're going to add that tax onto it, and we know it equals $38.16. So think about this when you go out to eat or out to a restaurant with your family and you all order a cheeseburger, and if there's 4 of you, well, the cost of the cheeseburger would have to be multiplied by 4, and then you add on whatever else you bought to equal the bill that you are given. So now we are given a couple of equations, and we need to figure out which variable can we put in to make each sentence true. So when we have an equation, like 2x minus 1 equals 5, there is one solution to this equation to make it true. So meaning there's one value of x that we can put in to make it true. If we just had 2x minus 1, we can have an infinite number of values of x because it's not telling us that it has to equal something. But as soon as it tells us that it has to equal 5, we know, okay, now we need to figure out what can we put in for x to make that work. So what I can do, I can plug in, so I can substitute 2, 3, and 4 into the equation to see what works. So 2 times 2, and I'm just going to write it like that just to remind me that it's multiplication, and it's subtraction, minus 1. So 2 times 2 is 4, minus 1 equals 3. So we know that that does not work. 2, so if it's 3, we're going to substitute 2 times 3 minus 1. We get 6 minus 1, which equals 5. And that does work. But just to make sure that I didn't make a mistake, I'm going to test the third one just in case. So then we have 2 times 4 minus 1, which is 8 minus 1, and that equals 7. And then we know that that doesn't work. So we know that this works, which means that x equals 3 for this equation. So my answer is x equals 3. If we have 34 equals 5y minus 4, if you want to pause and try this on your own and see if you can figure out which variable works, that'd be awesome. So I'm going to take y equals 3. I'm going to substitute it into 5y minus 4. So 5 times 3 plus 4, I think I said minus, it should be plus. So 15 plus 4 equals 19, which does not equal 34, so I know that it's not y equals 3. Then let's try y equals 4, so 5 times 4 plus 4, 20 plus 4 is 24. That does not equal 34, because remember my answer has to equal 34. That doesn't work. So now I'm assuming it's going to be 6, but I don't always want to assume. I want to check it to make sure. So 5 times 6 plus 4, 30 plus 4 equals 34, and that works. So my solution isn't 34. My solution is y equals 6. So that tells me that if I put 6 in there, that makes this statement true. All right, so last thing that you need to do today is you need to go back to the Schoology folder, which is Wednesday, February 3rd, under the to-do list, and find this Schoology check-in titled Expressions and Equations. Do it, complete it, use the notes from either yesterday or Monday, whichever day you were not on Zoom watching the video, and use your notes from today. Do your very best. Make sure you submit it when you're done. You have 3 attempts to get your highest score, and if you're feeling like you need more practice, definitely by all means go into iExcel, and you can go into this skill to practice expressions and equations. Have a great day, everyone.